So first we are going to with what is torsional test. Okay, so one of the most important and common mechanical stress strain test is a tension. Tension test means, I mean, that you have the bar. Okay, then you are going to use a machine where you can apply the load, or it's a tensile load. Okay, so that your specimen will get stretched. Okay, and if you continue increasing your load, the specimen will break down. So, and the graph, I mean, the machine will be connected through the system, and that will generate your graph. Graph will be of stress strain curve. Okay, and which we are going to discuss here right now. Okay, so this is the specimen. Okay, this is in the form of the rod or bar. Okay, circular bar. Okay, though you could have other rectangular bar as well. Okay, but the common one is the circular bar. This is the dimension, okay, that you have to follow. Okay, because every machine has their own standards. Without a standard you cannot make a specimen, and you are going to you know take a test that will not work. Okay, over there. Okay, so everything is according to their standard. Okay, so this standard is ASME E8. Okay, but you don't need to worry about that, but you just need to know what are the size that you required to make your specimen for tensile test. Okay, so as we will see, the tension test can be used to ascertain several mechanical properties of materials that are important in design. Obvious. Okay, a specimen is deformed usually due to fracture, where it will get deformed till fracture. I mean, the break, the material will fall down into parts. With a gradual increasing the tensile load that is applied uniaxially along the longitudinal axis of a specimen, a standard tensile specimen is shown as this is a specimen. What uniaxial means, you are just pushing, you are applying only on one axis. I mean, there is no such any forces over there. Only one force is working, which is uniaxially, and that axis and the applied load. I mean, the load that you have applied through which the axis is known as longitudinal axis. Okay. So this is your specimen. This one is a cross-sectional view. This is your cross-sectional view. This is your cross-sectional view. I mean, how it will look like if you will see from here. This is the cross-section view. So this is circular bar. This is the diameter 3 by 4. The all parameter has been given in inch. Okay, that you need. I mean, but in India, you need to just convert in a feet or mm. So mm is the best working unit. Okay, so this particular length is known as the gauge length. Okay, and this is the radii of the chamfer. Okay, that is given here, and this is as you can see, this diameter is something else, and this one is something else. So that, I mean, this particular area that will be go into the screw. I mean, the bar there it would be hold. This is kind of the holder basically. Both the side it will be hold, and this specimen will feel experiences of the load. I mean, just suppose you have clamped here, okay, and you have clamped here, okay. Now you are pushing this way, okay. Sorry, pulling this way, and now this one you are pulling this way. So on the both the side you are applying the same load, okay. But this and once the material will get fracture or breakdown, then you will have the graph on your system that will show you the stress strain diagram, okay, which is very common in material science and in strength of material as well. Okay, so this is your specimen. How the specimen look like? So you have seen here. Okay, this is this is a tensile test. If the same of I mean the same thing would be there, but you need to do the compression test. What does it mean? It means just everything would be same, but you just need to push the material specimen like this. You just need to push the material. I mean, and, you need to clamp the holder both the side, and then you need just opposite of the tensile. You are compressing the specimen, and when the material will get fracture, then you would have the graph that is known as a compression test graph. Okay, so if you see here, this is your specimen design. what should be the length, what should be the diameter. This all I have been, as you can see here, they have already mentioned that for your, you know, better understanding. Again, it has been written here. Okay, the specimen is mounted by the ends into the holding grips of testing apparatus shown as below. As you can see, this is apparatus. Yeah, look. So this all is your arrangement, which is known as UTM, Universal Testing Machine. Okay, this specimen, this is the gap. As you can see, this is your specimen that you have made. And this smaller specimen has shown here in a bigger picture. Okay, so this is the holder specimen, as you have a hold, and now this particular spring is showing here. This spring, this is also a spring. Once they have already all have set perfectly, the machine will start and it will try to pull the rod like this. So, so I mean, you're just pulling this one, and obviously it is fixed. So you are basically pulling this particular specimen to this. Okay, so this is the basically test.